Howdy, Dr. Morrow. Today we'll be discussing the use of thorium to power cars in the near future. Now, this is because thorium, has been calculated to be able to provide 200 million times the amount of free energy available from any other form of energy or energy resource, like oil, natural gas, coal, uranium, plutonium, etc. So, thorium. I want to give you a few basic facts about thorium. I'll explain how it works in conjunction with cars, and then we'll go into some environmental concerns. First, thorium number 90 on the periodic table is extremely dense, and that indicates that it could contain a lot more energy than other elements. There's very few other elements that are more dense, but thorium is actually, because even though it's not the densest, but it is easier to be used in nuclear reactors and to obtain energy from it. So, although it's not fissile, which fissile means it's almost more reactive, and therefore it requires a catalyst a lot of times to lower the energy barrier and enable us to use thorium to produce energy. But that's mostly for nuclear reactors, not for what cars are going to be going for. Now, Carlo Rubbia, a Russian nuclear particle physicist, has shown us that there's an extremely greater amount of energy available from that. You can see there's 1.3 million zetajoules of energy available from thorium, whereas the next highest is uranium, and we can already know that nuclear energy is highly underutilized. And then the most common forms, like oil and natural gas and coal, are nowhere near, with like coal has 200 zetajoules, but 200 versus 1.3 million definitely means that we're not being as efficient as we could be with our energy resources. Now, let's see, how would this work? How can a car manufacturer make this work for us? They basically want to create a miniature steam-powered engine in the car. So they would, we know this from, there's a prototype that Cadillac actually produced in 2009 to show us. I wish I had a picture of it, but Laser Power Systems and their CEO, Dr. Charles Stevens, shows us that they would use a laser and point it at this source of thorium, and they basically only need 8 grams of it to power a car for 100 years. So you can tell that's a very small amount of the resource, and you get a lot of potential out of that. It would actually save us approximately 7,400 gallons of fuel for every for those 8 grams. So there's a lot more potential there for preserving the environment and things like that, just by using thorium instead. So, like we said, he uses a laser to point it at it, which creates heat and heats water, and then from that we gather steam, which would spin a turbine and thus drive the car and power the car. They could use thorium in nuclear power. However, here I'm mostly interested in just how they could make it work for a car. Now, of course, there's an environmental aspect to this, because we understand that if we're saving so much energy and spending less fossil fuels, then we could spare the environment a lot of damage. So people are worried about, perhaps because thorium is radioactive, that it would have some sort of effect on bad effect on the environment. But it produces little waste, and the waste that it does produce doesn't last a long time. So it ultimately would create less or do less harm to the environment than, say, fossil fuels and coal might. Now, that means it would reduce carbon emissions, which again saves the environment a lot of damage. And although another aspect of this is that it could honestly change like the world kind of infrastructure economically, because Australia is actually has the highest amount or the greatest amount of thorium available. But overall, as we've seen, despite all the fears, radiation, environmental damage, the only thing prohibiting us from using this is basically a manufacturer. It's on the manufacturer side. So there's a lot of benefits to thorium right now, and it's underutilized at the moment. However, we'll see we'll see what happens with it in the future. I appreciate you listening, and thanks again.